Good morning, grade 10s. Today we are going to look at the introduction to trigonometry. I know to a lot of you, you guys feel like the word trigonometry kind of daunts you or scares you. And it may seem daunting at first, but I promise it's very, very simple, especially on the grade 10 level. And I trust that you guys are going to absolutely smash this. So let us begin. So what is trigonometry exactly? So trigonometry is all about the relationships between the sides and angles of a triangle. In grade 10, we are going to be specifically focusing on right-angled triangles. Previously, Pythagoras uses two known sides, right, to figure out the third unknown side in a triangle. So we used to use Pythagoras' theorem. And basically from that we could take the squares of each. The sum of the square of the two sides is equal to the square of the hypotenuse, and we would take that square over to become a square root on the other side, and we could solve the unknown side. In that case, it would be the hypotenuse. Trigonometry is only slightly different in the sense that now we are given one of the sides and one of the angles, and now what we can actually do is solve everything about the triangle. So we can solve obviously all the unknown angles in the triangle. If we have one of the angles and the other angle is a 90-degree angle, we know that the sum of all the angles in a triangle is equal to 180 degrees. So that makes our life nice and easy. But then we can still use trigonometry to find one of the other unknown sides, and then we can still, again, use Pythagoras if we must to solve the last unknown side. So we can solve everything about a triangle. And again, in grade 10, we are only going to be specifically looking at right-angle triangles. So let's begin. So we're going to start off by learning how we label a triangle. This is very, very important, okay? Basically, there are three sides to a triangle. They each have a specific name. It depends on which angle you are referencing. So which angle am I talking about? Let's isolate that angle, and then let's try and label our sides from that angle specifically. So each side is given a name depending on the relative position from a particular angle. And these are going to be our hypotenuse, which is always the longest side in the triangle. It lives directly opposite the 90-degree angle in our right angle triangle. We have the opposite side. That is the side that is furthest from the angle that we're referencing. And then we have the adjacent side, which is our angle that is touching and is adjacent to our angle of reference. Now, there are three commonly used symbols that we use to denote angles in a triangle that you must know about. The first one is theta. Okay, these are all Greek symbols. The second and third one are alpha and beta. And there we have the symbols for those now. So theta is, kind of the circle with the little hat coming off. Alpha is kind of like the proportionality sign that we use in physics. It is kind of, it looks like an A, but it kind of looks like a fish to me. And then beta is like this B, but it's like kind of like a graffiti type of B. It looks really, really cool. So that is theta, alpha, and beta. Those are the most commonly used symbols for angles in a triangle. Obviously, we can't use other symbols if we must, but those are the main three. Okay, so let's label the sides of the following two triangles. So we're going to start by identifying which angle is our reference angle. Okay, I'm going to start over here. In this case, my reference angle is theta. All right, that is the only angle they've given us. So how do we go about labeling this triangle now? So we know that the longest side in our right angle triangle is always going to be the hypotenuse, okay? So this is the hypotenuse. That is the longest side of our triangle. We know this is the hypotenuse because it's directly opposite our right angle in the triangle. Speaking about opposites, if we go directly opposite from this reference angle, we have our opposite side. So that would be our opposite side. Again, that is the furthest side from our angle of reference. It is also not touching, right? It's not touching this angle. Like this and that line, those two lines are basically forming our angle. So the line that is completely on the opposite side is what we call our opposite side. And then, last but not least, the last known side is going to be our adjacent side, and that is because it is touching our angle and is not our hypotenuse, of course. So that is our adjacent side. All right, let's go to the next triangle, because there are always two places we can put angles that does not include our right angle. All right, so this is now my reference angle, and we're going to start off with our hypotenuse. All right, this is our hypotenuse. That is because it is directly opposite our right angle in the triangle, and it is our longest side of our triangle. All right, if I'm looking for my opposite now, all right, directly opposite this angle on this side, we now have our opposite side. And if that is our hypotenuse and our opposite, this must obviously be our adjacent side, okay? This is our adjacent side. That is because it is touching our angle and is not our hypotenuse, of course. All right, so there you have it. That is how we label our right angle triangles. Notice how these two triangles, right, are basically the same, exact same triangle, but depending on which angle I'm referencing, right? If I reference this theta over here, my opposite lives on this side, okay? But if I am referencing this alpha angle, my opposite is on the opposite side, right? And that is because we are referencing different angles. So that will play a big part in which side is basically our adjacent and which side is our hypotenuse. Okay. Just check that I am still recording. I am. Good. Okay. So let us start by defining our trig ratios. All right. So we have three primary trig ratios that we deal with. They are known as sine, cos, and tan. Okay, so we have sine, cos, which is cosine, and tan, which is our tangent. All right, we we always abbreviate them like this, and you will see that these buttons actually live on your calculator, but we'll deal with that in just a minute. So what is sine, cos, and tan? Well, sine, cos, and tan are basically ratios of two sides of the right angle triangle. So if you remember doing similarities, right? When you're looking at two similar triangles, you are comparing the ratios of their sides, right? This is similar in a sense, okay? Except that we aren't comparing triangles. We are actually going to use trigonometry now to calculate with angles. So what is sine, cos, and tan? Well, we have a very, very nice, simple way to remember this, and I highly recommend that you write this down at the top corner of every page that you're doing trigonometry on. That's what I used to do. I used to just write this in the top right corner of every page, so I could just grab the information whenever I needed it, and I could actually solve my questions without thinking twice about it. So we have a saying, and it goes like this: so ka toa. Okay, so ka toa. So it's kind of sounds Hawaiian or like an ancient chant of some sort. Okay, so ka toa. And what SOHCAHTOA stands for is that the sine, okay, the sine is equal to, in this case, I'm just going to reference this triangle over here, all right? This would be obviously my opposite, adjacent, and hypotenuse for this specific triangle. And sine is the opposite, okay, the opposite over the hypotenuse. Sine is equal to opposite over hypotenuse. Okay, so sine is equal to opposite over hypotenuse. That is the definition of sine theta. Okay, for cos, what is cos going to be? Cos is going to be the adjacent over the hypotenuse. Cos is equal to adjacent over hypotenuse. Okay, and then tan, as you can imagine, is going to be our opposite over our adjacent. Opposite over adjacent. So there you have it. Those are our basically our trigonometry definitions for sine, cos, and tan. Okay, and again, a very easy way to remember this is SOHCAHTOA. You want to be writing this at the top of every single page in your test paper. Okay. Here is a quick fun fact, and I thought I'd throw in there. Where does sine actually come from? You know, where do these funny words come from that we are using in mathematics all of a sudden? And sine actually comes from the Sanskrit word for bowstring, okay, which means half chord, half chord. So just to be very brief, a chord in mathematics is basically a line that looks like this as part of a circle. I'm not going to go into too much depth here, but as you can imagine, let's just draw a little man drawing a bowstring here. Let's say that he's doing some archery. Actually, he would be holding it over here, so I've drawn him very, very weirdly, but you can imagine he's pulling back on a bowstring like that, okay? And half the chord is basically saying, look, this is half this chord over here. If I had to draw, you know, a circle around here, that is going to be half the chord. And if I take these two colors, we can see that from this reference angle over here, this is our opposite, and this is our hypotenuse. And this is kind of where the word originates from. And this dates back, I mean, thousands of years now. So just a nice little fun fact over there. Okay, let's dive into the good stuff. We're going to start with our first example. Example 1 basically says, write down the values of the following trigonometric ratios. Okay, we don't always say trigonometric, by the way, we just say trig, you know, trig ratio. So write down the values of the following trig ratios. Okay, we've got now sine of 60 degrees. Remember that this 60 degrees over here is just being replaced by theta over there. Okay, so our SOHCAHTOA still applies, and what I'm going to do to solve this problem, okay, is I'm actually going to immediately start by writing SOHCAHTOA, okay, at the top of my page somewhere, so I can quickly grab these whenever I need them, okay? So we need sine of 60. Now that's 60 degrees. They are referring to this 60 degree angle over here. That's what sine of 60 means. It means that I'm specifically referring to that 60 degrees, okay? So we know that sine of 60, okay, sine is equal to the opposite over the hypotenuse. All right, so you are more than welcome as a beginner to just write literally opposite over hypotenuse. You can also abbreviate that further. You can just go O over H if it makes you feel better. That is just helping me to basically identify, you know, which one, where is my opposite? I'm basically just going to take the value of my opposite and plug it in over there. I'm going to take the value of my hypotenuse and I'm going to plug it in over there. So if it helps you, please write this down first and then substitute it in. So let's quickly find my opposite. In this case, my opposite from the 60 is going to be the square root of 3. So I have the square root of 3, okay, divided by my hypotenuse, which is my longest line. in the triangle, which is 2 in this case. So it is the square root of 3 over 2. Okay? Let's have a look at cos of 60 degrees. Again, I will do the same thing. Cos is adjacent over hypotenuse. Okay? My adjacent in this case is this one over here. This is my adjacent, number 1. Use a highlighter in your test if you want. If this helps you, use a highlighter, or just take a pencil even, right? And just say, you know what? This is my adjacent, okay? This is my opposite, and this is my hypotenuse. You can go and write that on your triangle in your test paper, but just bear in mind that if you happen to have another angle over here, okay, in this case, this is going to be a 30-degree angle. If I'm referencing that 30-degree angle, now all of a sudden my opposite and adjacent have swapped around. And we'll see that in the next question. So my adjacent is 1 over my hypotenuse being 2. So it's a half, okay? Last but not least, we have tan of 60. Okay, tan is the opposite over the adjacent. So again, I'm going to do this. Whoops, opposite over adjacent. Okay, my opposite being the square root of 3, my adjacent being 1. So it's the square root of 3 over 1. Okay, and I recommend writing it as a fraction because it is a ratio at the end of the day. And look, yes, tan of 60 is equal to the square root of 3. Okay, you can type that in your calculator. Press the tan button. All right, type in 60 degrees. Close your brackets. Obviously, make sure that you've got that 60 degrees in brackets. Press the equal sign and see what pops out. Now, you must be very, very careful because at the very top of your calculator, sometimes you see a little sign that looks like this. It's very, very small. It's a dark symbol usually at the top of your calculator, a D. Sometimes there's an R, and I think there's some other symbols. Be very careful. Make sure that you're using this D, which stands for degrees. Okay, you must be working in degrees to get the correct answer. This R stands for radians. Okay, which is a different ball game, a different way that we calculate angles, okay? Make sure that your calculator is set in degrees, otherwise you are going to pop out the complete wrong answer. And the best way that I find that my calculator is set in degrees is actually just to reset my calculator completely. Okay, so reset your calculators if you haven't. Make sure that you are getting the correct values. Okay, so this is actually the exact same triangle, okay? Notice how I have my square root of 3, my 1 and my 2, just like the previous question. And because this is 60 degrees, and this we know is 90 degrees, this must therefore be 30 degrees. We know that all the angles in a triangle add up to 180 degrees. So this is the exact same question, and what do we expect? Do we expect to get the exact same answers as before? Let's find out, okay? So my sine of 30 is my opposite over my hypotenuse. Okay, again, now that I'm using a new triangle, maybe it is better that I quickly write opposite. It's going to help me a lot. I know that this is my adjacent, okay, and I know that this one over here is my hypotenuse. Okay, so sine of 30, okay, and only jump straight to your ratios when you are feeling extremely comfortable at this point, okay? It is the opposite, which is 1, over the hypotenuse, which is 2. Okay, let's compare our answers here. Notice how these two answers are actually completely different from each other. But notice how cos of 60 was a half. So it makes you think. Cos of 60 is equal to sine of 30. Okay, we'll deal with that later. Next up, we have cos of 30. Okay, cos of 30, that is my adjacent over my hypotenuse. Remember, use your SOHCAHTOA to solve this. Okay, adjacent over hypotenuse, that is the square root of 3 over 2. Notice how sine of 60 is equal to cos of 30. All right, just something to think about in the back of your mind. And last but not least, we have tan of 30, which is my opposite over my adjacent, which is 1 over square root 3. Okay, 1 over square root 3. There you have it. All right. Let's have a look at example 2 now. Example 2 says, write down the value of sine of theta, cos of theta, and tan of theta. Okay, so here is my theta. Okay, this is my reference angle over here. So we want sine of theta. Okay, now what I'm going to do is I'm going to write down SOHCAHTOA. Get used to it. Okay, SOHCAHTOA. And I can use this to quickly grab my definitions for each of these. Okay, so sine of theta, I know, is opposite over hypotenuse. Okay, so now let's quickly define who's who in the zoo here. My longest side is always my hypotenuse. Okay, this is going to be my opposite, and this is going to be my adjacent in my triangle. So we've got this opposite over the hypotenuse. Okay, but wait, let's have a look here. I have my opposite value of 12, I have my adjacent value of 5, but I don't yet have my value for my hypotenuse. And I know that I need to find hypotenuse, the length of the hypotenuse, if I'm going to be able to write down a value for sine of theta. Okay, how do we find the hypotenuse in this triangle? Well, we use good old Pythagoras. Okay, Pythagoras states that the longest side squared is equal to the sum of the other two sides squared. Okay, so my longest side, now be careful how you name this. This is AC. AC is our hypotenuse. So I can write AC squared, okay, is equal to AB squared plus BC squared. Okay. Now you are welcome to actually bring over, I'm a huge fan of rearranging my equations before I substitute in my values. You are more than welcome to substitute in your values of 5 and 12 first. But what I like to do is I like to actually go ahead and completely define mathematically what AC is before I substitute. So I've rearranged my equation. I just square rooted both sides, right? So my AC is equal to the square root of, now AB, let's substitute correctly, is 12 squared plus BC is 5 squared. Okay, so AC is equal to the square root. That is going to be 144 plus 25. All right, and 144 plus 25 gives me the square root of 169, which is going to be 13, if I'm not mistaken. Okay, and it's 13 what? Units. Okay, sometimes we do define the units. Sometimes we'll put meters or centimeters, okay? But if we don't define the units, okay, I like to just say, look, AC is equal to 13 units. Okay, so I'm just going to pop that calculation over there. What I typically like to do at this point is I like to, on my page, just in pencil, write, okay, look, I've solved for that. So that's a 13. I can now go ahead and use that 13 in other calculations that I need to do later. Okay, so that is our triangle. This 13 also makes sense to me, just very quickly. All right, that is 5, that is 12. The hypotenuse is always the longest side of our triangle, so that has to be greater than 12. There's no doubt about that, okay? If I got something silly like 9 or something like that, that doesn't make logical sense to me, because I know the hypotenuse is always going to be equal to the longest side of my triangle. Okay, with that being said, sine of theta is equal to the opposite over the hypotenuse. Okay, I'm going to write it nice and clean for us. The opposite being 12 and the hypotenuse being 13. Okay, cos we know is adjacent over hypotenuse. Okay, so my adjacent being 5, my hypotenuse again being 13. And tan of theta is always going to be my opposite over my adjacent. So that is going to be 12 over 5. And there you have it. I have determined the values of sine theta, cos theta, and tan of theta. Okay. Quick sip of tea. Okay. Next up, we're going to be calculating the sides in triangles. Okay. We typically use our calculators for this, and we use it to calculate the trig ratios of angles. Okay. For example, and you can do this in your calculator right now to check it out. Okay. Type in sine of 50 on your calculator. So press the little sine button, okay? You'll see sine pop up with a little open bracket. Punch in 50 and make sure to just close your bracket, okay? Whenever you open a bracket on your calculator, you need to close it, right? There needs to be an equal number of curved brackets on this side as there is on the other side to make sure that everything is closed under the hood. Okay, otherwise sometimes you get calculation errors and your calculator just absolutely breaks, okay? It doesn't know how to deal with that. So just make sure that you're always closing your brackets, please. And press the equal sign and see what crops up, okay? You should get 0,766, and these dots over here just means that, look, it's a recurring number that's going sometimes on infinitely, right? Okay. Try cos of 25. So type in on your calculator cos 25, make sure that all your brackets are closed and see what pops up on that side. And then last but not least, try tan of 33 and see what number crops up on that side. And we should get 0,649, blah, 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 blah. Okay? It should be noted that not all trig ratios are long decimal strings of answers, okay? Sometimes they are nice and neat and tidy. Okay, this is where our special angles usually come in, but I want you to quickly try these for me. Type in sine of 90. Type in sine of 0. Type in cos of 0. Type in cos of 90. Type in tan of 45 and type in tan of 0. Okay, what numbers do we get from that? Well, sine of 90 is going to be equal to a whole number, 1. Okay, and sine of 0 is going to be equal to 0. Cos of 0, on the other hand, is equal to 1, where cos of 90 is equal to 0. And tan of 45 is going to be equal to 1, where tan of 0 is going to be equal to 0. All right, that's just off the top of my head, so correct me if I'm wrong. I believe I'm correct on that. But what we find, right? What we find is between 90 and 0 degrees, we have a ratio of numbers, right? A number that is greater than 0 but less than 1. In all cases, right? Between 0 and 90 degrees, we're going to have these fractions. Okay, have a look here. Sine of 50, fraction. Sine of 25, fraction. Tan of 33 is a fraction. Okay? Tan is a slightly different one, but it is between 45 degrees and 0 degrees that we have that fraction. Okay, so just something to note there in the back of your head. All right. Example 4 is asking us to determine the length of the following sides of the triangle correct to 2 decimal places. So usually we always ask you to just go to 2 decimal places, at least 2 decimal places minimum. But I always like to round off to 2 decimal places. And please make sure that you're rounding correctly, okay? Numbers that are decimal places that are 5 or more, we round up. Decimal places that are less than 5, okay? So 0, 1, 2, 3, and 4, we are going to round downwards, please. So let's calculate the side AB. So I'm going to start off by just having a dissecting this triangle for a little bit. I like to do this. I like to look at my triangle, or look at no matter what I'm doing in maths, look at my situation first, just kind of analyze it a bit, get an idea of where I should start, okay? They're asking me for AB. So I know, okay, look, I'm going to need to find this line. Let's quickly look at what they've given me, okay? They've given me this angle of 25 degrees, and they've given me this 8 meters over here, all right? From my reference angle, I know that this is my hypotenuse, I know that this is my opposite, and I know that this is my adjacent. Can you see that? Okay. So before I even begin, I'm going to start off by writing down top of my page, so, ka, toa. I know I'm dealing with trigonometry. So I'm going to go ahead and write this down. The top of my page, stick it somewhere, wherever you want, just in pencil, and now you can grab that information whenever you need it, okay? Now they want the length of AB. They want the length of AB. Let's think about what information we have, okay? I've already highlighted it in yellow over here for you. We've got the 8 meters. We've got the hypotenuse. We've got 25 degrees. That means I can use that 8 meters as my hypotenuse, and I can use my 25 degrees to find AB. AB is my adjacent side. So I've got my angle, I've got my hypotenuse, and my unknown variable, if you want to think of that way. The side I'm looking for is my adjacent side. So what do I need? Hypotenuse and adjacent. Well, which one of my trig ratios uses hypotenuse and adjacent? Is it so? Nope. That is opposite in hypotenuse. Is it ka? Yes, cos. Cos is equal to adjacent over hypotenuse. Okay, again, I have, sorry, I left my angle out here. I have my angle, I have my hypotenuse, and my adjacent is what I'm looking for. So this equation is going to work perfectly for me now. Okay, so I'm going to use cos to solve my length of AB now. Okay, so let us begin. So I'm going to write cos of 25 degrees is equal to, now cos is adjacent over hypotenuse, adjacent being the line AB. So cos of 25 equals AB divided by my hypotenuse, right? Cos is adjacent over hypotenuse, my hypotenuse being 8. So I end up with this equation. Cos of 25 degrees is equal to AB over 8. Okay? We're going to do 4 more examples of these. So if you don't get it the first time, it's completely okay. Okay, we're going to do more of these. All right. Now that I'm over here, cos of 25 equals AB over 8. How do I get AB by itself? Okay? Basically, I need to bring this 8 over to this side. If it's a division on one side, it's going to be a multiplication on the other side. Okay? You can also think of multiplying both sides by 8 if that method works for you. Okay? What I end up with when I multiply both sides by 8, or I bring 8 to the other side, is I end up with AB is equal to 8 multiplied by cos 25 degrees. Okay? Now, I just want to show you something very here with the way that we write or express the mathematics in trigonometry. We don't always put this multiplication sign. We also don't usually put this multiplication sign like this. And we also don't usually put brackets over here. There's actually a very simple way to write this, and that is just 8 cos 25. 8 cos 25 means 8 multiplied by cos of 25 degrees. Okay, that is what that means. So just a nice little technical way that we typically write trig functions, okay? Now, what is that equal to? Well, all you have to do is punch that in directly into your calculator. Literally press 8 cos 25. Make sure to close the bracket in your 25 degrees. Okay, and what we find is we get 7,25 when I round up to the second decimal place. Okay, now what are our units? Well, they said it was 8 meters. So this is the length of a side AB. That means that this AB is 7,25 meters. You see that? Okay. Let's get the other side of our triangle. So I'm just going to pop this up over here. Okay. Now we are looking for the side BC. So that is this side over here. Relative to my angle, what is that? That is going to be my opposite side. So I need to use opposite. And now what I recommend you guys use is the side that is usually given to you. That is a perfect 8. Okay. What sometimes happens is we get this 7,25 with a decimal string that's constantly recurring, and then we round it off. And what we do is we take that rounded off number and we'll continue to use it in multiple calculations that come afterwards, but then we get what's known as rounding errors. Our complete equations start to deviate a bit. Okay, because we're constantly rounding off our values. So what I typically like to do, given the choice, I will always use this 8, okay, over something that I've calculated with a long decimal string, okay? So I, in this case, am going to choose my opposite and my hypotenuse, all right? Do we have a trig ratio that involves opposite and hypotenuse, okay? So if I go back to SOHCAHTOA, what do I find, okay? Well, sine is equal to opposite over hypotenuse. There you have it. The first one, okay? Chi, remember, is adjacent and hypotenuse, so we've already done that one. And TOA is opposite over adjacent. And again, you can use opposite over adjacent in this case, just that we're going to be using that long decimal string number we just calculated. So I, in this case, am actually going to opt for sine. Okay? So we know that sine of 25 degrees, okay, sine of 25 degrees, this is my 25-degree angle, is equal to the opposite over the hypotenuse. The opposite in this case is my line, which I define as BC. So it's opposite BC over hypotenuse being 8. And same thing as last time, I'm going to rearrange this. I'm going to bring this 8 over to this side now. And what I get is BC equals 8 sine 25 degrees. I'm going to punch that in my calculator now. So 8 sine 25 degrees. And what we find is we get 3,38 meters. Please don't forget your units. We are dealing with meters here. So I know that the length of this opposite is 3,38 meters. Okay, let's quickly check our answer to see if this makes sense. So we've got 7,25 there, we've got 3,38, and our longest side should be our hypotenuse, which is 8 meters. That makes perfectly good sense to me, so I am happy with this answer. Okay. Let's do another one, all right? Now, I might start speed running this a bit because I've gone quite slowly through this one. But this is just some more examples for you guys to get used to this topic, okay? So, I am going to start by having a look at my triangle. What have they given me? Okay, they've given me this reference angle, beautiful. They've given me this 12 centimeters. What side is this 12 centimeters? It is my hypotenuse, okay? It is directly opposite from my 90-degree angle. That means that on this side, I am going to have my opposite side, and on this side, I'm going to have my adjacent side. With that in mind, I can solve everything about this triangle now. All right, I'm going to start off by writing SOHCAHTOA, the top of my page, and then I'm going to start to solve. They want me to find DF. Okay, so DF is this line here, that is my opposite line. What information do I have? I have my angle in yellow there, and I have my hypotenuse. So I'm going to be dealing with my hypotenuse, my angle, and I'm looking for my opposite side. That is like my unknown variable, okay? So which one of my trig ratios incorporates both the opposite and the hypotenuse? Well, sine. sine of 50 degrees is equal to the opposite over the hypotenuse. So that is df is my opposite. My hypotenuse is 12. I'm going to multiply both sides by 12 and I get sine of 50. Oops. Let's start with df. I get df. Okay, all I'm doing is I'm bringing this 12 over to the side by multiplying 12 sine 50. Okay, so therefore my df, when you plug that into your calculator, I've just done the calculations here beforehand, 9,19. Okay, and what are my units? Centimeters. 9,19 centimeters. Guys, you are literally just plug in this, type on your calculator 12 sine 50. Okay, and you will pop out this answer. Again, if you're getting something completely different, make sure that your calculator is in degrees and not radians. At the very top, it's a tiny, tiny block. Okay, make sure your calculator is in degrees. Otherwise, you're going to be pumping out some weird numbers. All right, so that's our first answer. Next, we want the line DE. That is going to be this line over here. DE, that is my adjacent. Now, I know what my hypotenuse, my opposite is now. That is 9,19 centimeters. That's amazing. But I, again, am going to opt for using my hypotenuse to find my adjacent with, obviously, with this angle over here. Because my hypotenuse is a perfect 12, okay? So, hypotenuse and adjacent, what is that? Well, that would be adjacent and hypotenuse. All right, adjacent, hypotenuse. Adjacent is what I'm looking for. Hypotenuse is what I've got. So I'm going to use cos. So cos of 50 degrees is equal to my adjacent, which is DE, over my hypotenuse being 12. I'm going to multiply both sides by 12. So what I end up with is DE is equal to 12 cos 50. And when I pop that in my calculator, I am going to get 7,71 centimeters. 7,71 centimeters. Okay, so that makes this 7,71 centimeters. And let's check our answer quickly. My hypotenuse, which is 12, should be larger than my 7,71 and my 9,19. Okay, so that looks good to me. All right, let's do another one, okay? Now we are looking for GI. I'm going to start by analyzing my triangle. What angle have they given me here? 43 degrees. Okay, that would make this side my opposite. I know that my longest side is always my hypotenuse, and the side that is always touching this angle over here is my adjacent side. Okay, GI, okay, I'm just going to write SOHCAHTOA. Get used to this, guys. It's the easiest way to do this and not make any silly mistakes. GI, in this case, is my adjacent, okay, and the information they've given me is my opposite. Notice how I can't use my hypotenuse. I don't have any information for my hypotenuse yet. Okay, so I can't actually use my hypotenuse. So I have to use the information I have. What information do I have? I have the angle, of course. I have the opposite. So I have to use the opposite, okay? So I have two choices now. I've got this one or this one, because cos does not include the opposite. I've got the information for the opposite, so I have to use the opposite. So I've got two choices. Am I going to use sine or am I going to use tan? Okay, let's figure it out. So I've got my 43 degrees, I've got my opposite, and I'm interested in my adjacent, so I'm going to go with opposite over adjacent, which means that the function I'm interested in is going to be tan in this case. So I'm going to write tan of 43 degrees is equal to opposite 7 over adjacent, which is known as GI. GI. Okay. Now, we need to rearrange this equation so that we have GI as the subject of our formula. How do we do that? I have a very, very nice trick that I use. It's something I just, over years of doing this, you learn the tricks, but basically you just take the 7 and you pop it over the top there. That's what GI is. I call it the hat trick, okay? I call it the hat trick. When you want to find what this denominator is, okay, we can take whatever's in the numerator, and you can only do this when there's one term on the side, by the way, and you're allowed to just pop it over there. It's amazing, okay? There is a proof for it. If you want to prove it, you're more than welcome to, okay? So basically, what I find is my GI is equal to 7 divided by tan of 43 degrees, okay? So GI, if I type that into my calculator, type the 7, put your divide line, and then under that, write tan of 43, making sure to close any brackets that you might have open. And I get 6,53. And what are our units? Millimeters. 6,53 millimeters. That is the length of GI. 6,53 millimeters. Okay. Next up, we need to find the last side, which is going to be GH. So GH obviously being our hypotenuse now. So that is this line over here. What should I use now? I obviously have my angle. I'm going to choose to opt to use the opposite again. Okay, and now I want my hypotenuse, so I need my opposite and my hypotenuse. So I'm going to use sine in this case. So I'm going to say sine of 43 degrees is equal to 7 over my hypotenuse is called GH. Okay, therefore, if you rearrange this, you'll find that GH is equal to 7 over sine 43 degrees. So GH will be equal to 10,26 millimeters. And there you have it. We have solved those two sides. Okay. And here is the last example. I am actually going to let you guys do this one by yourself. So if you want to pause it, you can pause it now very quickly and calculate this for yourself. But otherwise, I'm just going to pop the answers on here quickly for you so that you have them. Okay, what we find is JK is equal to 8,91 kilometers. And we find that JL is equal to 14,15 kilometers. Okay.